pushes on to find alternatives to tropical fats such as palm oil. But is it economically viable to produce them in a fermentation tank?
Well, at NoPalm Ingredients, we make palm oil without palm trees. That's the easy way to explain it. And palm oil in itself is a beautiful product. It's cheap and it's versatile. No wonder it's used in over 60% of products in supermarkets. But there's one big problem. There's not enough. Our world is so hungry for palm oil. The supply can't keep up with the demand. And that's where we come in and we make a one-on-one replacement, a drop-in replacement with the same functionality at price parity, but also with impact, reducing carbon emissions by 96% and land use by 99%. I mean, palm oil is made from the palm fruit, and then it's chemically treated into different fractions, oleins, mid-fractions, stearins. Currently, we're scaling mid-fraction fats, but our platform is able to make all of these different fractions at price parity. The way we've been able to get that so cheaply is by setting up a low capex fermentation, like brewery type of fermenters, and using food industry waste streams as an input, lowering costs for raw materials, energy, and equipment. So we use oleaginous yeast. They produce fats by themselves. We do not genetically modify them, but we've used directed evolution to enhance their performance. So we've basically bred them in a way that they make even more oil than it's commonly known that they can make, making our process very productive and also playing a role in getting it to profitability and to price parity.
Can you share any numbers about how much oil as a percentage that they're producing?
That's up to 60%. So now we're scaling real drop-in replacements, but indeed our platform has the ability to make tailor-made oils and fats. And we do that by changing the parameters of the fermentation process. So changing conditions like temperature, pH, certain limitations, that allows, or basically puts the yeast under kind of a stress that they make different types of oil and fats, some more solid, some more liquid, and therefore we're able to make different fatty acid profiles that our customers can use in their products.
What would your ingredients be described as on a food ingredients or a cosmetics label, for example?
Yeah, it would be described as a fermentation-based yeast oil. So the first market we're going after is Europe. Demand is big in Europe, and at the same time there's regulation coming into effect banning deforestation-related products. So that's where all of the customers in Europe are looking for an alternative to palm oil that's as sustainable, deforestation-free, but at price parity and with the same functionality. And that's exactly what we bring together. Obviously, we're also trying to commercialize in the US, which is another big market where there's a lot of pull as well. But firstly, Europe.
Okay, can you tell me a bit more about feedstocks?
Yeah. So we use food industry waste streams, side streams, whatever you want to call it. We've been using this technology on about 20 different types of feedstock, from whey permeate, potato peels, carrots, you name it. We know it works. At one point we had to pick one to scale because every feedstock requires a different type of protocol, different types of settings, and to develop that you need a few months, so you only can pick one and scale that. We're planning to scale a second and third feedstock later this year and beginning of next year. But it's key in getting this this technology at price parity.
So when it comes to the levers, again, you can pull to drive the efficiency of the process. I mean, you've touched on this a bit, but what kind of innovations are you excited about that can kind of improve the unit economics of your process?
Yeah. Well, I'm excited about a few things, and I'm not sure that I can share these here, but our team is looking at like alternative ways of downstream processing in a way that we can lower costs even more significantly, lower cost of the downstream processing part by about 90%. Can't really disclose how we're doing that, but first signs are very promising and very excited of what they have in store for us.
So can you tell me a bit about your manufacturing setup, where you're based? Would this be something you would look to scale up in-house or with a co-manufacturer or through a partnership with a strategic or something?
Yeah. Yeah, currently we're based in Wageningen in the Netherlands. So we've only been around for 3.5 years.
Yeah.
We have obviously our laboratory set up. We have a pilot line with a 400-liter fermenter. Scaling to 120,000 liters that we've done so far, we've done at a CMO. But the next step for us is to build a demo factory, which will be in-house to control the process from A to Z completely without relying on third-party manufacturers. And that's because we're process innovators. We need to have it in-house. Other than other companies that might be able to work with CMOs and scale it there and then build a commercial facility, our technology requires us to take that second step and have that in-house.
And what would be the scale of the demo?
The demo scale would be around 2 fermenters of about 50 cubic meters, so 50,000 liters. So that would be able to produce about 1 kiloton, 1.2 kilotons a year. In order to make real impact in this industry, in this market, you need to be at price parity or even a green discount. What I've learned in the past 3.5 years is the single most important buying criteria is price. So that's why when we started, my co-founder and myself, we set out that we needed to have a process that has the same functionality, but also the same price. So we made design decisions always having in mind, what does this do with unit economics? So we're now even at the productivity rate that if you extrapolate in terms of scale, renders price parity, versus other approaches where you would basically make a process as efficient as possible and then work your way down the cost curve by making it cheaper. But then you've made certain design decisions that you cannot backtrack from, and so you have a certain floor. And that's, I think, the way how we've set it up in a smart way and has enabled us to reach price parity at scale today already.
So when you say price parity at scale, what scale would you be talking about? Would that be at 150,000 litres?
That would be about like 6 fermenters of 150,000 litres each.
So how have you funded the business so far, and how challenging is it to raise money in the current environment?
Yeah. We raised 2 rounds, a pre-seed round and a seed round, so about total 6 million euros. Raising in this environment is difficult. Raising funding in Europe is, I think, even more difficult, I could argue. But it's all based on metrics. So if you deliver on your plan and execute on it, and take real steps in proving that this works, so scaling it to 120,000 liters at a productivity, getting first offtake agreements, getting co-location agreements, getting regulatory confirmation, those things really help building the fundament and helping convince investors that we're almost ready to take the next step to a demo scale.
In your view, the fact that your organism can consume these agricultural sort of byproducts or waste products versus having to buy in kind of purified D95 sort of sugars, is that pretty significant part of your value proposition, or are a lot of companies in this space now using these other feedstocks too?
I think it's an important element of our proposition. Our business model is one to co-locate, so our vision is to have small factories across the globe upcycling food industry waste streams on site, and us selling and distributing the oils and fats. And having that footprint allows us to scale quickly and fast. Whereas if you would, for example, source glucose, you'd probably choose to build one big factory. And I think we've all seen that building big factories in this industry is pretty darn difficult. And we're actually reducing complexity by that co-location, decentralized approach.